Let's solve 16 is equals to 6 cosine pi over 6x plus 14. What's the general solution? We're trying to find the possible values of x in which this equation makes sense. Let's do some algebra. We have an equal sign here. We're going to throw the 14 over. 16 minus 14 is 2. Now we're going to divide both sides by 6. So 2 divided by 6 is going to be this expression here. Notice how you're not allowed to multiply. You're not allowed to cancel out these 6's here, because this is actually an angle on the inside. There's a hidden bracket here. So what we have here is we have some ugly angle. So why don't we make this ugly angle a bit more beautiful by letting theta equals pi over 6x. So now the question here becomes cosine x is equals to 2 over 6, which reduces to be 1/3 over here. Okay, so we're talking about the this cosine trig function. Something to keep in mind is that this is the b value. This is function transformations. The b value is pi over 6. Recall that the period of sine and cosine is 2 pi over b, the absolute value of b. So the period of this cosine function is 2 pi divided by pi over 6. When we multiply by the reciprocal, and the pi's cancel out. We have 2 times 6, which is 12. So just keep in mind that this is not exactly the normal cosine graph. This is actually a bit stretched wider. Okay, so going back to this algebra here, we have a very classic trig equation. Trig of some unknown is equals to some number. Unfortunately, this number is not special. It's not like 1/2 or -1/2 or negative root 2 over 2. So unfortunately, we do need to use a calculator. So how do we find it out here? We attack this normal trig question by going Haya, ASTC, and we need 2 checks. It's positive. The number 1/3 is positive in quadrants 1 in A and C land. Cosine land, all things are positive land over here. Now we need to hit the inverse cosine button for 1/3. Make sure you're in radian mode, because we're talking about radians. You see the pi there, and for the angle we're in radian mode. So check your mode. Make sure you're in radian mode. Okay, so we're going to hit cosine inverse of 1/3. Enter. And we have 1.23 radians, which is about this. The quick way to figure out if you want to know where to draw it is by multiplying by 57. This is just a super rough way of getting the degrees. 70 degrees is around here. But even if your diagram is not the scale, if you accidentally make the stick a bit too low or a bit too high, it doesn't really matter. You can still figure out the answer. Okay, so this is the first answer, and this traveling all the way around is going to be the second answer. Now we think we're done, but actually we're not. We're not done yet. Please do not stop. So trig equations, there's a lot of steps, so people do get lost, but once you get used to the pattern of how things work, you're going to get lots of points on these type of problems. So recall that we try to simplify life by making theta is equals to pi over 6x. So we're trying to solve the original question, which is talking about x, not theta. So we're going to replace theta with pi over 6x, and this happens to be equals to 1.23. We're going to multiply both sides by the reciprocal such that this coefficient of x cancels out. And when you multiply this using a calculator, we get 2.35-ish. This is a real solution. Now the general solution is going to be plus minus the period n. Please do not make the mistake of writing 2 pi n. People always think the general solution is 2 pi n, but the general solution is going to be plus minus the period n, and we previously figured out that the period was 12. So this is a very common cause of mistake, so be careful. And as for your other theta value, we have the second theta value is going to be all the way around here, which we figured out was going to be 5.05. And we're going to replace theta with pi over 6x again. It's approximately 5.05. We're going to multiply both sides by the reciprocal of the coefficient here. Pi over 6 cancels out as long as you multiply by 6 over pi. use a calculator, we have about 9.65. And this is the actual real solution. To find the general solution, we go plus minus the period n. So these are your general solutions. You can get an infinite number of correct solutions to this equation as you change the n values, and n can be any integer. It could be 0, it could be 1, 2, negative 1, 2, 3, etc.